You open your eyes. The sky is orange. Not the orange of a sunset, not the warm orange of a fire or a lamp or anything you have seen before. This orange has no source. There is no sun you can point to. The entire sky glows, every direction, every angle, the same dull, burning orange, as if the air itself is on fire from the inside. You sit up slowly. The air pushes back, not like wind, like weight, like the air has mass, has intention, has been waiting here for a very long time and does not particularly want you to move through it. You breathe in, and then you understand that breathing here was a mistake. The air of Venus is not air. It is mostly carbon dioxide. It is laced with sulfur. It is the atmosphere of a planet that was once perhaps something like Earth. And then something went wrong. Something went very, very wrong. And it has been wrong ever since. You are on Venus, the most hostile surface in the solar system, and it is already working on you. Venus is Earth's twin. That is what scientists called it for a long time. Same size, same mass, same distance from the sun roughly. When the first astronomers looked at it through their telescopes, they saw thick clouds and thought, perhaps oceans underneath, perhaps jungles, perhaps life. They were wrong. Venus is not Earth's twin. Venus is what Earth could become if everything that keeps Earth livable stopped working at once. The atmosphere of Venus is almost entirely carbon dioxide. It is 90 times thicker than Earth's atmosphere. It traps the sun's heat the way a sealed car traps heat on a summer day. Except this car has been sealed for billions of years. The surface is 465 degrees Celsius, all the time, day and night, pole to equator.
And there is almost no temperature variation on Venus because the atmosphere is so thick that it distributes heat evenly across the entire planet.
You cannot find a cool spot. You cannot find shade. The heat is not coming from above. The heat is coming from everywhere. If you placed a block of lead on the surface of Venus, it would melt. You are not lead. You are considerably less durable than lead. In this story, you are on Venus. You do not know how you got here. That question is going to become less important very quickly. What matters now is the orange sky above you, the weight of the air around you, and the heat that is already moving through every layer of what you are. 1. The sky, what wrong looks like. You stand up. The first thing you notice is the weight. Not your weight, the weight of the air itself. On Earth, you do not feel the atmosphere pressing on you. It is always there, pushing down and in from every side, but your body has spent its entire existence inside it and has learned to ignore it completely. Here, you cannot ignore it. The atmosphere of Venus presses on every square centimeter of your body with the force of 90 Earth atmospheres. This is the pressure you would feel 900 meters below the surface of the ocean. Deep sea divers train for years to handle a fraction of this pressure. Their equipment is engineered over decades to resist it. You have no equipment. You feel it in your chest first, a tightness. Not pain, not yet. Just the specific resistance of lungs that are trying to expand against something that does not want them to expand. Each breath costs more than the last. Each breath is a small argument between your body and the planet is not losing. You look up at the sky. The orange is everywhere. You look for the sun. On Mercury, the sun was overwhelming, was the first and only thing you saw, was impossible to miss. Here, the sun is invisible. The clouds are too thick. The clouds of Venus stretch across the entire planet in a layer that starts roughly 50 kilometers above the surface and extends upward from there. They are thick enough to hide the sun completely. They are thick enough to turn whatever light gets through into this orange. This sourceless, directionless, eternal orange. There are no shadows. This is what you notice next. The light comes from everywhere equally, diffused through hundreds of kilometers of cloud, until it has lost all direction. Nothing casts a shadow.
You look at your hand, and your hand has no shadow. You look at the rocks around you, and the rocks have no shadows. Everything is equally lit from everywhere, and the effect is wrong in a way that takes you a moment to identify. Then you identify it. It looks like the inside of an oven. The rocks around you are dark gray, almost black in places, with a surface texture that speaks of extreme heat held for a very long time. Not the heat of a fire that burns and passes. The heat of a place that has been this temperature for millions of years and will be this temperature for millions more. These rocks have been slow cooked by the planet itself. They have never been cold. They do not know what cold is. The heat of Venus is different from any heat you have experienced. Heat normally has a source. A fire is hot in front of you. The sun is hot from above. A stove is hot to your side. There is a direction to the heat, a place it is coming from, and you can turn away from it. You can step back. You can put something between yourself and the source. On Venus, there is no direction to step away from. The heat is in the air. The heat is radiating from the ground beneath your feet. The heat is coming down through the clouds from the sun that you cannot see. The heat is stored in every surface around you, and every surface is giving it back. You are standing inside the heat. You are surrounded by it on every side, above and below and left and right. And every molecule of the thick, heavy air that presses against your skin is carrying 465 degrees worth of energy directly into you. Your skin knows this. Your skin is reporting it with increasing urgency. The specific feeling of extreme heat on skin is not simple. It begins as warmth. Then it becomes discomfort. Then it becomes something past discomfort that the body does not have a good word for. Something that occupies the space between pain and alarm. Something that says, this is not sustainable. This needs to stop. Please make this stop. You cannot make it stop. You look around for something. Shade, shelter, a gap in the rocks. Anything that puts something between you and the heat. There is nothing. The rocks are too flat, too low, too cooked by their own stored temperature to offer relief. The sky offers nothing but more orange. And the ground radiates upward. The air presses inward. You start walking. Not because walking will help. Because standing still feels like surrender. The surface of Venus beneath your feet is made of hardened lava. Almost everything on Venus is made of hardened lava. The entire planet resurfaced itself roughly 500 million years ago in a catastrophic outpouring of volcanic activity that buried everything that came before it. Billions of years of history erased. The surface you are walking on is young by planetary standards. Young and hot and entirely indifferent to the distinction. You see the rain before you understand what it is. High above you, something is falling from the clouds. You can see it if you look carefully. Long, thin streaks in the orange sky, like rain seen through a window. It's visible only because they catch the diffuse light slightly differently than the air around them. It is not water. The clouds of Venus are made of sulfuric acid. Not the thin, diluted sulfuric acid of a car battery. Concentrated sulfuric acid in droplets, falling from clouds 50 kilometers above you. The clouds produce rain, the way Earth's clouds produce rain. The rain just happens to be one of the most corrosive substances that forms naturally in the solar system. The rain does not reach the surface. This is the one mercy Venus offers on this particular point. The surface is so hot that the acid droplets evaporate long before they land. Somewhere between the clouds and the ground, perhaps 10 or 20 kilometers up, the falling acid hits hot enough air and turns back to vapor and rises again to form more clouds. Venus recycles its own acid rain. The cycle has been running for millions of years. You watch the streaks in the sky. You know they will not reach you. You feel no relief about this because the things that will reach you
are already here. The pressure, the heat, the air you are breathing, each breath a small toxic transaction between your lungs and an atmosphere that was not built to sustain you. Your throat has a quality to it now that was not there before. A raw quality. A scraped quality. The air of Venus contains sulfur dioxide. In small amounts on Earth, sulfur dioxide irritates the throat and the lungs and causes discomfort. You are not breathing small amounts. You are breathing the full atmosphere of Venus with every breath, and the sulfur is doing what sulfur does when it finds tissue to work on. You breathe through your nose, then through your mouth. There is no version of breathing here that does not cost something. You think about the probes, the Soviet probes that were sent to Venus in the 1970s and 80s. Venera, they were called. Venera 7 was the first to survive landing. It transmitted data from the surface of Venus for 23 minutes before the heat and the pressure destroyed it. 23 minutes. The engineers celebrated. 23 minutes on Venus was considered a triumph of human engineering. You have been here longer than that already. Venus is not silent. This surprises you. On Mercury there was no sound at all. Nothing to carry it. The silence there was the silence of the vacuum, the silence of the universe itself, complete and total and almost peaceful in its completeness. You expected something similar here. But Venus has an atmosphere, a very thick atmosphere, and thick air carries sound better than thin air. Low sounds especially, the kind of sounds you feel in your chest more than you hear with your ears. There is a sound here, a low sound, constant, coming from everywhere the same way the light comes from everywhere. A deep pressure sound, the sound of 90 atmospheres of gas in constant slow motion. The sound of the wind at the surface of Venus, which moves only slowly but carries so much mass in each gust that slowly means something different here than it does on Earth. You feel the wind before you hear it properly. It is not strong by any measure you would normally use for wind, perhaps a few kilometers per hour, a gentle breeze on Earth, on a mild afternoon. But this is not Earth. This is air that is 90 times as dense as Earth's air, and when 90 times as much air moves against you, even slowly, the force is not gentle. The force is the force of something very heavy, moving with patience rather than speed, pushing on you from the side with the specific pressure of something that does not need to hurry. You lean into it. You correct your balance. The wind shifts slightly, and you correct again. You are spending energy just staying upright, just standing on the surface of Venus in a wind that would barely move a curtain on Earth. Requires continuous adjustment. Your legs are working. Your core is working. Everything is working against the weight of the air and the push of the wind and the heat that is pulling resources from you with every passing minute. You look at the horizon. The horizon on Venus is closer than it should be. The atmosphere is so thick that it bends light. Light curves downward as it travels through the dense air, which means the surface appears to curve upward at the edges. You are standing in a bowl. The horizon rises slightly on every side, like the edge of a shallow dish. If you had the right equipment, and if Venus were not Venus, you could theoretically see around the curve of the planet, and the light would carry that far. You do not have the right equipment. You look at the curved horizon, and you breathe carefully, and you try to take stock of what you are working with. The answer is, not much. Your body is a machine designed for a specific set of conditions. A narrow range of temperatures, a specific atmospheric pressure, a particular combination of gases. Take away any one of those conditions, and the machine struggles. Take away all of them simultaneously, and the machine starts shutting down in the specific order that biological systems shut down when the conditions they need are no longer present. You are in that process now. You have been in it since the moment you opened your eyes. You walk to a large rock, and you sit down. The rock is hot. Of course it is hot. Everything on Venus is hot. And the rock is not hot the way a rock in the sun is hot on a summer day. It is hot the way an oven rack is hot.
The kind of hot that does not ask permission. The kind that communicates through your clothes without hesitation, and then through your skin, and then deeper than your skin. You stand up again. You look at the rock. It is dark basalt, volcanic, the same kind of rock that forms from lava when lava cools. Except on Venus, the cooling was never quite complete. The rock never reached room temperature because there is no room temperature on Venus. There is only Venus temperature, which is the same everywhere, weighs 465 degrees, the number that the planet settled on 1 billion years ago and has not moved from since. The rock has a surface like nothing you have touched before. Not that you can touch it long, but you look at it closely, at the texture of it. The way the surface has been worked on by heat and pressure and the slow chemical processes of an atmosphere that is not air, but is dense enough to be a kind of ocean, to move over these rocks the way water moves over the rocks at the bottom of the sea. The atmosphere of Venus, over millions of years, leaves marks, reacts with the surface, slowly transforms it. These rocks have been sitting here, being transformed since before your species existed. They will still be here, still being transformed long after the last trace of your species is gone. You look at them the way you look at something very old. You are the newest thing on Venus by a margin so large it has no useful comparison. Your vision is different now, not blurring, not failing, different. The orange of the sky is the same orange it was when you woke up, but your perception of it has changed. Colors shift when the body is under stress. The brain processes things differently when it is managing multiple emergencies at once. The orange is brighter, or you are more aware of it, or some combination of both, the brain turning up the gain on everything sensory, because everything sensory is information, and information is what a body in crisis needs. You notice your hands. They look right. They feel wrong. The pressure of the atmosphere is acting on your body the same way water pressure acts on a diver who goes too deep. It is looking for the weak points, the places where the outside and the inside meet, your ears, your sinuses, the small spaces within you that are filled with air at earth pressure, that were built for earth pressure, that are now in an argument with 90 atmospheres of Venusian atmosphere about what pressure is supposed to be. You feel it in your ears first, a deep ache, the kind that comes on airplanes when you descend too quickly. The pressure changing faster than the small systems in your ears can equalize. Except here, the pressure will not equalize. Here there is no equalization. The pressure outside is 90 times what your ears were built for, and your ears are doing their best, and their bet is not going to be enough. You swallow. You try to clear the pressure. It does not clear. You keep walking because stopping means thinking about the pressure, and thinking about the pressure means thinking about all the other things the pressure is doing that you cannot feel yet. The slow internal work of 90 atmospheres against a body built for one. The ground slopes upward ahead of you. You walk up the slope. Venus has mountains, real mountains. The highest, called Maxwell Montes, rises 11 kilometers above the average surface level, taller than Everest. There are valleys and plains and highland regions, and a geography as complex as Earth's. From orbit, the planet has a surface. From the surface, the planet has a horizon. It is a real place, a planetary body with real geography, with history going back to the formation of the solar system. You climb the small slope. At the top, you stop. The view is the same as below. Orange sky, dark rocks, the thick air making the horizon curve upward at the edges. But the act of climbing, the act of having gone somewhere and arrived somewhere, matters. Your body needed to do something purposeful, to make a decision and execute it. You made it to the top of a small rise on Venus. You stand there and breathe the terrible air. You look at the orange sky. Something moves in the sky. High up in the cloud layer, something shifts. The clouds of Venus move at 360 kilometers per hour at the altitude where they live. They circle the planet every 4 Earth days, driven by winds that have been blowing for millions of years. Far below them, you are standing on a surface where the wind barely moves. Two different planets stacked on top of each other. The surface Venus and the cloud Venus. You are on the surface Venus. You are on the wrong one. You sit down on the warm, dark rock at the top of the rise. Your body has given you permission to sit. It has been running the numbers all morning, and the numbers have produced a recommendation. And the recommendation is sit down. Your legs accept this without argument. You look at the sky. You think about Earth. Venus and Earth formed at the same time from the same material 4.5 billion years ago. For perhaps the first billion years, they may have been similar. Venus may have had oceans, it may have had a mild climate, and it may have had the conditions that on Earth eventually produced life. Then, the oceans boiled. The water vapor rose into the atmosphere. Water vapor is a greenhouse gas. More water vapor meant more heat. More heat meant more evaporation. More evaporation meant more water vapor. The cycle fed itself, each step making the next step worse, until all the water was gone, and the heat was locked in, and the carbon dioxide built up, and the pressure climbed, and what was left was this orange sky, this impossible heat, this air that is not air. Scientists call it a runaway greenhouse effect. Runaway. The word is accurate. The process ran away from any equilibrium that could support life and kept running until it hit a new equilibrium that could not. Venus found its equilibrium. It has been in that equilibrium for billions of years, and it is perfectly stable. It is perfectly hostile. Earth is also in an equilibrium. Earth's equilibrium is more delicate. You think about this, you think about the specific thickness of Earth's atmosphere, which is thin enough to let heat out at night and thick enough to hold warmth during the day. The specific balance of gases, the specific distance from the sun, the specific presence of liquid water, which Venus lost and never got back. You think about how narrow the margin is. You think about how long it holds. You breathe in the sulfur-touched air of a planet that did not hold its margin, and you think, this is what wrong looks like when it has had 1 billion years to become permanent. Your breathing is harder now, not because of the sulfur, though the sulfur is there, and it is working on the soft tissue of your throat and your lungs, the way sulfur works on soft tissue. Harder, because each breath has to fight the pressure to happen at all. Your diaphragm pulls down and the atmosphere pushes back, and your lungs expand slightly, not fully, never the full breath that a human lung was designed to take. You are breathing in small increments. You are getting less oxygen per breath than you need. Your body is rationing. The heat has been in you for a while now, not just on your skin, in you. Through the skin and into the muscle and spreading outward from there, through the tissue, the way heat moves through everything, following the gradient, flowing from hot to less hot, from the 465-degree air into your 37-degree body, with the unstoppable efficiency of physics. Your core temperature is rising. The human body is very good at regulating its temperature. It sweats, it redirects blood flow. It does a dozen small things automatically, constantly, to keep the core within the narrow range that the organs require. But these systems were designed for Earth. They were designed for a planet where the air temperature, even at its worst, is a fraction of what surrounds you now. They are running at full capacity, and they are losing. So your heart is working harder than it should. Your heart is trying to compensate for everything else. More blood moving faster, trying to distribute resources, trying to manage the heat, trying to keep the pressure from winning. It is a loyal organ. It has been working for you since before you were born, and it is working for you now, here, on the surface of Venus, doing everything it knows how to do in a situation it was never designed to face. You lie back on the rock. The rock is hot against your back. You look up at the orange sky. You look up at the orange sky and you see the acid rain, still falling somewhere far above, still evaporating before it lands.
the planet's endless cycle running above you the way it has been running for millions of years. The acid falls and evaporates and rises and forms clouds and falls again, and over, without pause, without purpose. Simply the chemistry of this atmosphere following the rules that chemistry follows everywhere. There is a kind of peace in watching it. Not peace because it is beautiful, though the orange light has its own terrible beauty. The beauty of enormous things that do not care about you, peace, because it is simply what it is. Venus is simply what it is. It did not become hostile to punish you. It did not arrange its atmosphere to harm you specifically. It arrived at this state through billions of years of physics and chemistry and the logic of heat and pressure, and the state it arrived at happens to be incompatible with the state you need to exist. That is all. You are incompatible with Venus. Venus is indifferent to this. You think about the probes again, the ones that lasted 20 minutes, 30 minutes, a little more. The engineers who built them, and the scientists who designed them, and the people who watched the data come in from the surface of another planet for the first time in human history. They were trying to understand this place, trying to learn what Venus was. And Venus transmitted its answer clearly, through every probe, in the same language every time. Heat, pressure, acid, silence. The answer was always the same. The answer is the same now. Your eyes are open. The orange sky is above you. The light is the same as it has been since the moment you woke up here. Sourceless, directionless, the same dull burning orange in every direction. The light of a sun you cannot see, filtered through layers of cloud and acid and 100 kilometers of dense hot atmosphere until it arrives here, at the surface. Without shadows, without angles, without the specific quality that makes light feel like light rather than just illumination. But you look at it now, and you see something you did not see before. Depth. The clouds have layers. You can see them now in a way you could not see them earlier. Subtle variations in the orange, slight differences in shade and thickness. The upper cloud layer and the lower cloud layer, separated by differences too small to notice when you were upright and moving and focused on staying upright and moving. Lying here, looking directly up, not moving, your eyes have time to find the detail. The clouds are moving. Slowly at this altitude, just above the surface. A slow drift from west to east. The wind up there, in the upper layers, is 360 kilometers per hour. Down here, it is barely a breeze. Somewhere between the surface and the clouds, the speed changes. The atmosphere, transitioning through speeds and temperatures and densities. A planet with multiple weather systems stacked on top of each other. You watch the clouds move. Very slowly. Your breathing is very slow now too. The two slownesses match. The slow clouds and the slow breath, both moving at the speed that this moment requires. The pressure in your chest has changed. It is not the tight fighting pressure of an hour ago. The argument between your lungs and the atmosphere. It is something quieter. Your lungs are not fighting anymore. The fight took too long and used too much, and now there is only the breathing itself. Each breath accepted, rather than demanded, shallow and slow and still real. You are still breathing. You are still here. The orange sky is enormous above you. The rocks around you are warm. The acid falls somewhere above and evaporates and rises and falls again. The wind pushes slowly against your face. You let it. Venus is the brightest object in Earth's sky after the sun and the moon. People on Earth can see it right now if the sky is clear, as a bright point of light near the horizon at dawn or dusk. They call it the morning star. They call it the evening star. They look at it and see light. They see something beautiful. They do not know what the light is made of. They do not know what the brightness is hiding. You know now. You are inside the brightness. You are looking up from the inside of the morning star. The last thing you think about is water. Not water you want right now, though you want it. Your body has been wanting it since the first breath of sulfur-touched air, and has been wanting it more each hour. Not water as a practical matter, water as a memory. You think about water the way it exists on Earth, rain on a window, a glass of water on a table in the morning, the specific sound of a tap, the weight of a full glass, the cold of it against the inside of a mouth. Venus had water once. The scientists believe this. The evidence points to it. Ancient Venus, billions of years ago, may have had oceans, may have had rain that reached the ground, may have had rivers. The water is gone now, gone into the atmosphere when the planet got too hot, gone into space when the solar wind stripped it away over billions of years. Every molecule of water that Venus ever had is somewhere else now. You think about what it would look like. A blue ocean on Venus, under a sky that was not yet orange. A young planet, still in the process of becoming. Before the balance tipped. Before the heat found its feedback loop and followed it all the way to this. You cannot picture it. This orange, this heat, this weight, this is the only Venus you know. The orange sky above you is very bright. The orange sky above you is very still. The clouds move slowly in their layers. The acid falls and does not land. The heat is everywhere. The heat has always been everywhere. It was here before you. It will be here after. A note of science. Venus is the second planet from the Sun and the closest planet to Earth. It is almost exactly the same size as Earth. It orbits the Sun in 225 Earth days. It rotates so slowly and in the opposite direction from most planets that a day on Venus is longer than a year on Venus. The surface temperature of Venus is 465 degrees Celsius. This temperature does not vary significantly between day and night, or between the equator and the poles. The thick atmosphere distributes heat so efficiently that the ender planet has essentially the same temperature everywhere. It is hotter on the surface of Venus than on the surface of Mercury, despite Venus being further from the Sun, because Mercury has no atmosphere to trap heat, while Venus has an enormous one. The atmospheric pressure on Venus is 92 times the pressure at sea level on Earth. This is equivalent to the pressure at a depth of approximately 900 meters in Earth's oceans. The clouds of Venus are made primarily of sulfuric acid droplets. They cover the planet completely and reflect about 70% of the sunlight that hits them. This makes Venus the brightest object in Earth's sky after the Sun and Moon. The high reflectivity is the reason Venus was so visible from Earth long before we understood what the planet was actually like. The Soviet Venera program sent a series of probes to Venus between 1961 and 1984. The earlier probes were destroyed before reaching the surface. Venera 7, which landed in 1970, was the first spacecraft to successfully transmit data from the surface of another planet. It survived for 23 minutes. Later probes lasted up to 110 minutes before the heat and pressure destroyed their electronics. The images they sent back showed a barren, rocky landscape under an orange sky. Scientists believe Venus may have had liquid water oceans early in its history, perhaps for as long as 2 billion years. A runaway greenhouse effect triggered by increasing solar output as the Sun aged is thought to have evaporated the oceans. The water vapor entered the atmosphere, amplified the warming, and the planet eventually reached its current state. Understanding how Venus lost its water is considered important for understanding what could happen to Earth under certain conditions. Next, Mars.